state space. This kind of assumes you watched the other two, or we talked about the physics and matrix stuff before. So make sure you know that before doing this, because otherwise you're gonna be very lost. But yeah, sorry to out of order, but the whole goal of like state space modeling is to create a model of your system with math, okay? So instead of just physics, like, oh wow, torque equals something, or F equals ma, right? We need to put everything into matrix form, because that's math, and computers understand math a lot better, okay? So we always start off with this, our x, okay? As you've noticed, I call this the state, okay?
Why was she so mad?
Just like in programming, right? The state kind of is keeping track of all the important variables we need to like keep track of, right? It's kind of redundant, but whatever. In this case, because it's just a little arm here, right? With your little motor, your little arm, whatever, all you need to keep track of is your theta and your theta dot. And your theta dot is just, you know, d theta dt. That's all that is, right? The dot basically just means derivative. And it's very useful to know, right? Just like in calculus, how your state is going to change in the very next instant, right? So again, from calculus, we borrowed this idea of the derivative, right? So what's the derivative of our state? It's a little harder to talk about that, right? Because instead of just one variable now, like y, we now have two. We have theta and theta dot, right? So to kind of work with that, we create a new array or a new matrix, right? With theta dot and theta dot dot. So the first derivative and the second derivative of our theta. And how we get this, you're not going to believe this. We just add a dot to everything. Okay, we're taking the derivative of everything. Cool? Okay. Second thing you need to know. This over here, this is x dot, right? There's a control law, a very famous control law that you kind of just need to know for this class. It's ax plus bu, okay? So this x here comes from your initial state, right? So this theta dot thing. This u is basically your input. You can think of it as user input, okay? And the homework, they just said, okay, your only input to the system, right, is u equals torque, okay? That's it. And from the previous video, we know that, hey, torque is equal to moment of inertia times angular acceleration, which is just I times theta double dot, because that's what angular acceleration is. It's just the second derivative of your theta, okay? So that's how I plug this thing here, right? So if I plug it into our equation, we get theta dot dot equals a times the state matrix plus b times this I times theta dot dot. And just again, a quick refresher, this I here is just like moment of inertia. It's like mass, it's like just like a number. So in your actual homework, I think it's something like 0.5. But I'm gonna leave it as I because, you know, I'll show you why that matters later. It's just like a variable, so treat it like mass or something, okay? And just something to note, we have a and b here, which are unknown, but they are not random, okay? They come from the physics, they come from the bounds of our system, they come from the math, okay? So it kind of seems like we're just randomly choosing a and b, right? But they actually do come from something, okay? It's not random, okay? And for this problem in particular, your A is going to look something like this. It's going to be A, B, C, D, so it's going to be a 2x2 matrix, and B is going to be some like 2x1 matrix, okay? How do I know that's going to be the shape of this thing, okay? Let's look at our linear algebra a little bit, right? So I know eventually this matrix multiplication, this is matrix multiplication, right? It's going to be one matrix, and this is going to be another matrix, okay? They both have to add up to this state matrix here, and this is a 2x1 matrix. Okay, this is a 2x1 matrix. Okay, so if I want to get a 2x1 matrix over here on the left, right, I have to make sure that this one is also a 2x1 matrix, so I can add it to another 2x1 matrix. So eventually they become one more 2x1 matrix. Okay, so for that to happen, right, we need AX to be a 2x1, right? So if this is if this is x, right? If this is a 2x1, and I need to get it to be a 2 by 1. Okay, from law number, let me see if I can find it. Law number, I said it over here. Law number 2, or like no, law number 1 actually. The rows and columns must match in order to multiply matrices together. Okay, let's see here you have a 2 by 3 and a 3 by 5. The 3 matches up. Okay, so here I know that, hey, in order to do matrix multiplication, the 2 must match up. So make sure we have a 2 here. Okay, then from law number 3, right? The resulting matrix will have the shape of the left guy's row and the right side, or the right guy's column, right? See how we need a 2 by 1 matrix, right? So the column is correct, right? See how this is a 1, this is a 1, this is good. But we need the 2 here, right? So that must come from the left side. So this must also be a 2. So that's how I know, hey, A has to be a 2 by 2 matrix, okay? Let's do the same thing for B, right? Okay, the inner must match up, right? So this must also be a 1, very cool, right? And this column here is taken care of, right? So I need the left side to also be a 2 in order to get that. And I'm now taking a quick break because you're actually calling me in real life. So we'll finish this for ourselves.